Today we're going to be solving another AMC 10 problem. Let T be the triangle in the coordinate plane with vertices 0, 0, 4, 0, and 0, 3. Consider the following 5 isometries, rigid transformations of the plane. Rotations of 90 degrees, 180 degrees, and 270 degrees counterclockwise around the origin, a reflection across the x-axis and reflection across the y-axis. How many of the 125 sequences of 3 of these transformations, not necessarily distinct, will return T to its original position? For example, a 180-degree rotation followed by a reflection across the x-axis followed by a reflection across the y-axis will return T to its original position, but a 90-degree rotation followed by a reflection across the x-axis followed by another reflection across the x-axis will not return T to its original position. So, in order to solve this problem, we'll first draw a diagram. So here I have my y-axis, here's my x-axis, so we'll label them. Now we'll actually draw a triangle. So one vertex is the origin, 0, 0, another is 4, 0, and 0, 3. So here's our triangle. Now, what should we do to this triangle? Well, we're doing transformation. So, what do we want to first notice? Well, first of all, 125 sequences. Well, we want to change that maybe. Since 125, it's a lot, especially since we're doing 3 again. So what do we notice? Well, whenever I do a 90-degree rotation, then if I do it 125 times, then I'll return back to a 90-degree rotation. Why? Well, after doing a 90-degree rotation 4 times, it will be a 360-degree rotation. A 360-degree rotation is an identity rotation, which means it will map the triangle back on itself. And 125 is 1 mod 4. So we just do 1 times 90. Now, using the same tactic on all of the others rotations, we'll get that 180 degrees is 180-degree rotation. The 270-degree rotation, 125 times, is just another 270-degree rotation. And then the reflections. Well, if we reflect any reflection twice with the same line, then that'll just be an identity reflection, which means that T will map onto itself. And because 125 is odd, we can tell that an x-axis reflection 125 times is equal to just an x-axis reflection again. And then on a y-axis reflection 125 times is just equal to a y-axis reflection once. Now, what does this mean? Well, if we do any of these 5 rigid transformations, then it will just be the same as doing them once instead of 125. So this makes it simpler. Instead of doing 125 sequences, we just have to do 1. Now, this helps us simplify it a lot. So now let's actually go to what these 3 transformations can be. So here, let's make the diagram again. 0, 0, 4, 0, 3, 0. Well, okay. The first thing we want to see is reflections, since reflections change the orientation. And what I mean by this is that if we do a reflection across the x-axis, this negates all of the y values. So this point is 0, 3. This becomes 0, negative 3. And then this point is 4, 0. This becomes 4, negative 0, which is equivalent to 4, 0. And then same with 0, 0. So we see that whenever we do a reflection, like here, let's just remove these labels for now. Then, no matter how much we rotate it, it won't go back. At max, it'll just come right here again. So what do we realize? We have to do another reflection. So let's say I'm back to my original case here. Then if I do a y-axis reflection, I'll get this. Now if I rotate this 180 degrees, I'll map my triangle T prime prime back to T. So, what does this solve? Well, we must have an even number of reflections. So, all of these possible number of reflections these two don't work. And that simplifies it much more, because now we can just do casework. So let's say 0 reflections. Now what does this mean? Well, that means that we need an identity rotation. And what is that? Well, once again, it's just a multiple of 360-degree rotation. So in order to do that, well, one more thing that we first have to clear is, let's say I do a 90-degree rotation, a 180-degree rotation, and a 90-degree rotation. This is different than a 180-degree rotation, and then a 90-degree rotation, and then another 90-degree rotation. So, because these two cases are different, we must also separate them differently. So, out of the possible sets that we have, well, we just have 90, 180, and 270. We can only do these rotations. Then, we must realize that whenever we do a rotation, let's first choose two numbers. So the amount of possibilities is just 3 for the first one, and then 3 for the second one. Now we have to see if any of these cases won't work. So what do I mean by that? Let's just say, arbitrary choice, I choose 90, 90 as my first two values. Well then, no matter how we do this, the next third value must be 180. So we just need to find the cases now in which we can't have a third value. So no third value exists that's in this set. So what case would that be? Well, let's take 90, 270 this time. We see that no matter what rotation we do, it won't be an identity rotation, because it'll be 360 plus some x, which means that it'll just make itself somewhere here maybe. So this makes us realize that we have three possible cases: 90, 270, 270, 90, and 180, 180. So we subtract 3 from this to get 6. Now, the next case is 2 reflections. So let us assume that I do 2 x-axis reflections, since I'm going to split this into two cases. The first case is same reflection. So if I do 2 x-axis reflections, then I'll map t back onto itself, so that's a good thing. But we have to do a third one. That's where it's not so good. Since we have to do a rotation, we realize that this is just the same thing as this problem here. So we realize that this has no cases. This will lead to 0. Then we go to 2. Different. Well, we see that, as one of the example states here, we have a 180-degree rotation followed by an x-axis followed by a y-axis. So what does this show us? Well, we have to arrange this as well. So we have 3 different objects, and the amount of ways we can arrange them is 6 factorial. My bad, it's 3 factorial. And this is equal to 6. Now let's sum these two. So, simply 6 plus 6 equals to 12. So therefore, our answer is A. Please like this video and don't forget to hit the subscribe button. Thank you.